Module 7, problem number 8. The data in the accompanying table represent the population of a certain country every 10 years for the years 1900 through 2000. An ecologist is interested in finding an equation that describes the population of the country over time. Complete parts A through F below. And we see there the icon for the data table. Let's look at part A. Determine the least squares regression equation treating year as the explanatory variable. Choose the correct answer below. All right, let's go ahead and open our data set, and then let's go ahead and open it in StatCrunch and turn off that pop-up blocker. All right, so first let's go to Stat, Regression, Simple Linear. We're going to select year as the X or explanatory variable. Remember, that's the independent variable. Y is dependent on X, so Y is or population is the response variable. What I'm going to do, well, I'll show you later actually. Let's go ahead and click compute and we'll get our regression equation. We can see it right here. So Y equals negative 30, what do we have here? 3 million. And then our slope is 1999. So let's see where that puts us. Slope, well, once we run it, it's 2000. That's our slope. And then negative 3. So we looks like option A is the answer. Check answer. Good job. All right. Part B, a normal probability plot of the residuals indicates that the residuals are approximately normally distributed. Test whether a linear relation exists between year and population. Use the alpha equals 0.01 level of significance. State the null and alternative hypothesis. Choose the correct answer below. Remember, so in order for us to test whether or not there's a linear relationship, we want to know if that slope is close to 0 or not. Remember, that tells us our correlation in this situation. So in this case, we're going to look at beta 1. And we're going to say our null hypothesis beta 1 equals 0 and beta 1 does not equal 0 as our alternative. Check answer. Well done. All right, determine the p-value, the hypothesis test. The great thing is that it's already done for us when we found our linear regression line. Let's take a look over here. See, we were looking at slope, that's right here, and we come all the way over here and we can find our p-value. It's 0.0001. So once we round that to 3 places, it's just 0. Check answer. Excellent. All right, state the appropriate conclusion. Remember, our alpha is 0.01. Obviously, with a p-value of 0, we're going to reject the null hypothesis. So we know we're looking at A or D. Let's read the conclusion. There is sufficient evidence to conclude that a linear relation exists between year and population, or there is not sufficient evidence. Remember, in this case, our alternative is that there is sufficient evidence. So if we're saying we reject the null hypothesis, that means there is sufficient evidence to conclude that a linear relation exists between year and population. So we're going to reject that null. Nice work. All right, draw a scatter diagram treating the year as the explanatory variable. Choose the correct graph below. So we're going to go to graph, scatter plot. We're going to select X and Y and click compute. And we're just going to compare our result to the options. So it looks right there like it's option A. Let's just double check it. See? Yeah, see how it's got a positive linear pattern there. So that's option A. Final check. Good job. All right, part D. Plot the residuals against the explanatory variable. Year. Choose the correct graph below. Just before we even get into that, here on the x-axis, that's the year. Your residuals are up here on the y-axis. Remember, your residuals are a measurement of how far your actual data was from the predicted value. So if you were to take your data that you used to develop that model and put it back in through your model, what was the output? And this is looking at the difference there. So it's a measure of, like, I hate to say it, but air quotes, how good your model is to fit to the data. So what I'm going to do really quick, I'm going to exit out of that one, but I'm going to show you if you were to, let's start over and run our linear regression, because there's an option in there for which graphs to retain. And one of them is the residuals against the explanatory variable. So we're going to go stat, regression, simple linear. Again, we're going to select X and Y, and we're going to scroll down. See where it says graphs you can keep. So let's scroll down to residuals versus X values. Again, X values, residuals. Residuals versus X values. So it tells you right there. Click compute. Now, you don't see it at first, but remember we were running a regression, so it gives you your regression results on the first page. Got to click the arrow over to get your plot. Looks like we have kind of a pattern here, like a U-shaped pattern almost. So of the options, that's option A. You see that U-shaped pattern. This one looks like a linear line. This is pretty scattered, but this has a clear U-shaped pattern similar to what we just saw. Final check. Excellent. Does a linear model seem appropriate based on the scatter diagram and residual plot? So one of the things that we learned this week is when this plot, this residual versus your X values, shows a pattern, you probably don't have a linear relationship, or that's not the right word. It's not appropriate to use a linear model because you have a pattern to those residuals. So even though there's a linear relationship based on the hypothesis test above, it's not appropriate because the residuals have a pattern. See here in option C from the last one, it was pretty scattered. If those are the results we saw, it would be more appropriate, but that's not what we saw. So the answer here is no. Final check. Fantastic. What is the moral? So there's a few options here, a little longer than our other options. So I'm going to read through them. The moral is that the inferential procedures may indicate that a nonlinear relation exists. Now, that's not what we saw. Our inferential procedures showed that a linear relation exists. So we're going to go ahead and skip to the next one. The moral is that the explanatory variables may indicate that a linear relation exists. That also does not match. We don't have explanatory variables. We had one explanatory variable. That's not the right option. Let's look at C. The moral is that the inferential procedures may indicate that a linear relation between the two variables exists, even though the diagnostic tools, such as the residual plots, indicate that a linear model is not appropriate or is inappropriate. Okay, and that's what we just talked about. So here in the case that the hypothesis testing, the inference that we ran up above showed that there was a linear relation. However, that curved pattern of the residuals told us that no, a linear model is not appropriate in this case. So that's option C. Final check. Well done. All right, that's problem number 8. If you have any questions, let me know.